Okay, so in this lesson, we're going to look at designing and building circuits, and it's all kind of working towards this learning outcome. So students should be able to design and build simple electronic circuits. So generally, when engineers are making, when they're making electronic circuits, or if they're building some kind of a device, what they do is they go through a design process. And this here is a simple design process that you can follow. So the design process is a series of steps that engineers follow to come up with a solution to a particular problem. So it's a series of steps that you can follow. Many times the solution involves designing a product like a machine or electronic circuit that carries out a certain task. And it is common to design something, test it, find the problem, and then go back to make a modification or change to the design and test it again. So you get this repetition of the process. So this is a nice simple process to think about when you are designing and coming up with your circuit in relation to designing and constructing a circuit. So the first kind of thing that an engineer will ask is like, what am I trying to, what's the problem? What am I trying to solve? So ask to identify the need and constraints. So what am I trying to do and what do I have? So what are the electronic components, for example, that are available to me? Then you might go and do a little bit of research. So you might decide do a little bit of research on the problem. Imagine possible solutions. So come up with ways to imagine how you could come up with a solution. The next then is to plan by selecting, promising a solution. So this stage should offer a number of solutions. And then this stage here, you pick which one is the best idea. The next then is to create a prototype. So that's like a mock-up of the circuit that you're trying to build. Then you want to test it, see if it works, and then you might want to make some improvements to it. And that's what you do here in this stage as well. Okay, so a simple example, like if we were, imagine you wanted to design an electronic circuit that turns on or turns off a light depending on how dark or bright it is. Okay, so that would be the question that you'd ask. So you go and do some research. So you think about the components that you'd need. You come up with possible solutions, like how could you do that? You'd then decide based on the ideas that you've come up with a plan. You might build your prototype circuit and then you might test it, see if it works, and then you might improve upon it then. And you might go back and forth in this stage here as well. So it is common to design something, test it, and find the problem, and then go back and make a modification to change the design and test it again. So this is all part of the design process. You will come up against problems, and it's about thinking about how do you overcome those problems. So we look at two simple designs that you could follow in relation to designing a circuit. So the first one is this design here. So many applications of light-dependent resistors and term resistors involve a sensor circuit to detect changes in light, intensity, or temperature. So again, remember these dependent resistors, light-dependent or temperature-dependent resistors, they allow the circuit to sense the environment. In this example, as the temperature of the term resistor is increased, its resistance falls and more current flows through the circuit. The increased circuit allows the motor connected in series to start moving. Okay, so this is like design a circuit to activate a cooling fan when the temperature rises. So this is a simple circuit that will do that. So we're going to look at this circuit in a little bit more detail. So this here is our circuit. So essentially what this does, so here we have this guy here, which is it's a resistor that changes resistance based on temperature. So you'd have this kind of a setup here. So imagine this is resistance. We measure resistance in ohms. Okay, so this is high. So high resistance, and then you have low resistance. And then along here you have temperature. Okay, so temperature, it might be, so for example, low. And then here it's going to be high. And what will happen is you'll get this kind of setup. So when the temperature is low, the resistance is going to be really high. It's going to be up here. And then as the temperature increases, the resistance of the resistor decreases. So it can be in two states. So if we think about it, let's look at these two states that this resistor can be in. So imagine this is the resistor, these are the resistors. Okay, so this is when it is, so you have low temperature. So it's going to be low temperature and it's going to be high resistance, and we'll just use the ohm symbol to represent resistance. And then here it's going to be high temperature. And it's going to be low resistance. So it's going to be low ohms. So when the temperature is low, you can think about the resistor, so it's going to be very resistant to the flow of electricity through it. So imagine, and then this one, when the temperature is high, the resistance is going to be very low. So imagine, so this is an electron here. So imagine this is our electron. So when the resistor is in this state here, okay, it's going to be very hard for the electron to actually move through this. So what will happen is the flow of electricity will be reduced, okay, because you can see that the path that the electron has to take through this temperature dependent resistor when the temperature is low is difficult. And then as it gets hotter, what you can think about it, it's like the resistor expands. So when the resistor expands, what that does is it enables the electron to easily move through it. Okay, so you can see here the electron can easily, it has loads of space, it can easily move through this resistor when the temperatures are quite high. So what happens is this then acts as like a sensor. It can actually sense the temperature of the environment. So when the temperature of the environment is really cold, it's very hard for the electrons to actually move through this part of the circuit. So imagine, so this is the path that the electron's going to take. So the flow of electricity is going to take this path, and then it's going to come up against this resistor here. So if the temperature is really low, if it's really cold, this section or resistor is going to be in this state, and the electron is going to find it very hard to move through. And when it can't get through, you're not going to get enough electrons moving through this motor in order to make it turn. Okay, so then when the temperature gets really hot, so what's going to happen is the resistance of this thermoresistor is going to decrease. So it's going to be in this state when it's hot. And then as a result of that, it's going to be much easier for the electrons to move through here. And when the electrons are moving through like that, you're going to have enough electrons moving through this motor in order to make the motor turn. So what's going to happen here is, like, this is a motor and it's going to be attached to a fan like so. So imagine this is the fan. And when it is hot and there's enough electricity flowing through this circuit, what will happen is it'll turn the fan on. And when the fan is turned on, you're getting electrical energy is being turned into movement energy or circular kinetic energy, and you basically get the fan turns on. So what this circuit basically does is it detects this light or temperature dependent resistor allows the circuit to sense the environment. If it's too cold, it doesn't let enough electricity flow through the circuit to turn the fan on, so the fan is off. If it's too hot, or if it gets hot, the resistance in this reduces, so it allows the flow of electricity through the current, and as a result of that, it turns the fan on, so it cools down the room or whatever it is that's in the room. So this is a simple, if you like, this is a temperature sensor, so it detects the temperature in the room and then it turns on and off a fan based on the temperature in the room, and this is how it works based on the flow of electricity through the circuit. So that is the so that would be designing a circuit to activate a cooling fan when the temperature rises, and this is kind of like what it would look like. So here you have your battery, here you have your fan, and here you have your temperature dependent resistor. So when it's cold, the fan is off. Okay, so it's just in an off position, and then if you like apply heat, like heat is being applied here, it will actually turn the fan on. So what's going to happen is when this resistor gets hot, it allows electricity to move through it, and when the electricity moves through it, it turns the fan on. So that's one type of circuit that you can design. So the next type of circuit is this one here. So this is a light sensor. So in this example, the light on the light dependent resistor is increased. It increases its resistance when it falls, and the potential difference across it would also fall. And this would cause the bulb to dim. And if the light dependent resistor was completely covered, its resistance would be at its maximum value, and the potential difference would also be at the maximum value, and the bulb would shine brightly. And this could be used as a simple light operating circuit for the bulb. So basically what this does, and we look at it now in a bit more detail, so this sensor, it detects, so basically it's a simple circuit that when it is bright out, okay, it will turn the light off, and when it is dark out, it will turn the light on. So it's a simple sensor that turns on and off a light depending on how bright or how dark it is outside. So let's look at this example in a bit more detail. So this is our light dependent resistor. So our LDR, light dependent resistor. And we can think about this. It's going to have two states. So imagine this is our graph. So we have resistance, which is measured in ohms. So this is high resistance, and then this is low resistance. And then what you have then is you have the light. So let's say this is dark, and then this is bright. Okay, independent. So what you're going to get is you'll get this kind of a setup here. So basically what's happening is in the dark, the resistance is really high, and then when it's bright, the resistance is really low. So if we think about it, it's this section here is going to be in two states. So you'll have this state here. Okay, so when it's dark, so imagine this is the path that the electrons have to move through. So it's going to be high resistance. And then you're going to have this when it's bright. So it's going to have this kind of a path. So this is your electron here. So electron, and then this is your electron. So when it's dark and this sensor is in the dark, the resistance is going to be like this. So basically the electron, it's going to find it very hard to actually move through this portion of the circuit. Okay, so this is going to, when it's dark, the resistance is very, very high. So it's going to be up here. It's going to be like in this state here. And as a result of that, the electron, it's going to be very hard for the electron to be able to move through this circuit. On the other hand, when it is very bright out, like when it's like this, it's going to be down here in this stage here. Okay, so in this state here, where it's going to be, the resistance will be low. So as a result, the electron can easily move through the circuit and then move out the other side. So you can think about when it's in the dark, this section is closed. When it's in the bright, this section is open, and it allows the electron to move through it. That's what we mean by resistance. So if we have a look at this circuit then, so what's happening here? So this here is a light. So depending on how much current is flowing through the light will determine the brightness of the bulb. So if there's a lot of current flowing through it, if there's a lot of electrons flowing through this bulb, it'll be very bright. If there's very little electrons moving through it, it'll be less bright. Okay, it'll be in the dark. So think about then the movement or the path that the electrons are going to follow. So what's going to happen is they're going to move like this through the circuit. They're going to go through this resistor, and this resistor will kind of slow down the movement of the electrons, and then they'll come to this junction here. And when they come to this junction here, so they can go this way, okay, and down through the bulb, or they can go this way. Now, when it's dark, so imagine, so when it's dark out, this section of this resistor here is going to be in this state here. Okay, so high resistance. So it's going to look something like this. Okay, so the electron is going to come along and it's going to try and move down through here, but it can't move down through here because the resistance is really high. It's going to be in this state here. So as a result, the electron will have to move in this direction. So what will happen is most of the electricity will flow down through the bulb and they'll continue on in this direction and it'll complete the circuit. And as a result of that, the more electricity, so you'll have very little electricity flowing across this portion here, and you'll have a lot of electricity flowing through this portion here. So as a result of that, the bulb will be shining really brightly. So that's when it's in this state here, okay, when it's in the dark. Now if we take the same circuit and let's say it's in the light, or it's bright, so imagine that it's bright. So what's going to happen, and the same thing is going to happen. So the electrons will move in this direction. They'll move down through the circuit and they'll come to this junction here. So are they going to go this way or are they going to go that way? Well, when it's bright, so the resistance across this light dependent resistor is going to be way lower. It's going to be in this state here. So imagine, so it's in this state here. So because it's in this state, it's much easier for the electrons to flow through it. So as a result, what you're going to get is the majority of the flow of electricity will actually move through this resistor, move through here, and complete the circuit. Now, some of the electricity will move in this direction, and it'll go through the bulb, but there won't be enough current going through the bulb in order to turn it on. So what will happen is the bulb will be essentially off, or it'll be very low. The light coming from it would be very, very low. So essentially that's the way that this particular circuit works. And this here, so this, when you set up two resistors in series like this, it's what's known as a voltage splitter. It just basically splits the voltage coming from the battery. So that's a simple design circuit that you can use in order to, so this circuit basically what it'll do is it'll detect the light that's in the environment, how bright or how dark it is, and it'll turn on and off a light depending on how bright or how dark it is. Okay, so that is the design process that you can follow when it comes to designing and building a circuit. And then we looked at two simple examples of electronic or circuits that you can build in order to turn on and off a motor when it's hot or cold, or turn on and off a light when it's dark or bright. Okay, thank you for listening.